Hey everyone, Dankman here. So you have this handout, Linear Context Review, and it says that the graph below shows the height of a tree that Alexis bought from a nursery and then planted in her yard. Now I'm going to talk about the graph and annotate it, and then you're going to be left with these questions to finish, and later in your teams you can check over the questions and discuss. So let's look at this graph together. Whenever you do look at a graph with context, meaning some kind of story or extra information about what it represents outside of the quantities and variables and etc. themselves, whenever you look at a graph with context, the first thing you should probably do is check what the graph is about. And the way you do that is you check the axes. So the x-axis here, the input, represents the years since this tree was planted. So looking at that, it goes from the negative values into the positive values. So it looks like since planting means that Alexis planted the tree here at 0 years since planting. This is after planting, which means to the left in the negative region is before the tree was planted. So the tree had a life before Alexis planted it. The other value we're looking at is height measured in feet, and that's our y-axis, which is the output. Okay? And we can see this curve representing the tree's height versus time is an increasing curve, which means that as the tree gets older, it also gets taller. Okay? An important point to take note of is right here, the point 0, 4.5. Okay? If f of 0 equals 4.5, then the input is 0 years since planting. So 0 years since planting means when the tree was planted. And 4.5 represents its height in feet. So it was 4.5 feet tall. Okay? And any point that you pick along this line will have the same type of pattern. For instance, -3 years, so that means 3 years before planting, 3 years before she bought and planted it, the tree was 0 feet tall. So like a seed maybe in the ground. So maybe actually it could be even a little bit negative, as we've discussed before. We can also break this graph down in terms of the growth rate of the tree. The growth rate of the tree can be visualized using a slope triangle, okay? Where the change in the x-axis and the change in the y-axis measurements are compared. So if you start from 0, 4.5, and you go along the line to 2, 7.5, the change in x is from 0 to 2. So the change in x is 2. And the change in y goes from 4.5 feet to 7.5 feet. That's a change of 3. So we can see that the slope of this line is the change in y over the change in x, where the y output value is height in feet, so that's 3 feet. So it grew 3 feet, and the change in x is 2 years. So it grew 3 feet in 2 years, and simplifying that fraction, we get a unit rate of 1.5 feet per 1 year. This is the growth rate of the tree. So now we know everything about this mathematical model. We know the starting value for the tree, which is that when it was planted, it was 4.5 feet tall. And we know the growth rate of the tree, which is that every 1 year it grows 1.5 feet. And we got that by looking at the input and output of the graph and reading every point along this line and analyzing its rate of change or slope. Now go ahead and complete the sentences, or the questions rather, that follow.